Hi folks, welcome back to one of my many videos. So let's go for it, okay? Um, so what we're doing here is, this is a topic called optimization. It's to do with calculus and differentiation. So we're taking here a little rectangle here, and we always start off with something basic. 6 meters by 4 meters, and it's made of aluminium. That doesn't matter. So what we're going to do is we're just going to remove some corners from this box here, and we're going to try and make it into a box. So, and just to show you, I've got a wee video here, and so this video might not actually work. You won't be able to hear the sound here, so that's why I'm talking over it. I'm just going to cut some corners out of this wee bit of paper here. Right, is that okay? Jeez, that's magic. That's so magic, that. You're just going to cut them out there. Oh, where's it gone? Oh, here's what I made earlier. Oh, crispy cutting it. You can't hear this. I can. If you've got children or even adults or partners in your house, this is this is really good to do a wee bit of craft in your house. It's really therapeutic. Why don't you try it? Actually, and I'm being serious here. So for my topic, which is maths, it would actually help you um, get on with things. Right, so we're nearly there. We're on the we're on the we're on the fourth corner, and if you're old enough, it's fourth corner, four candles. You can go and Google, Ronnie Corbett, Ronnie Barker. Right, so we're nearly there. Right, so we'll go once we've got basis of a box here. Right, so we'll get rid of all the four corners, but we can still do something with them. So what we're going to do then, Tommy? Oh, we have a probability. Pick a card, any card. Probability is they'll be all the same. We're going to fold up the sides here. Right, do you get that? Right, and I'm not going to move this on here. I'm going to, because you can actually zoom it on yourselves. Yeah, zoomers. I'll let you just look at Tommy's brilliant artwork. This is what they do in the industry. I'm telling you. I'm saying this is not going to be perfect. It's not going to be perfect. But do you know what? It's going to be near as perfect as possible. Oof. Oh, look at nearly there, Tommy. Oh, that's looking good. Can you see it in the middle? That's the base, right? And so we're folding up the sides, side rectangles, and it looks like, oh, we're making in a box. Oh, excuse, I'm getting so excited here. I'm so excited. I just can't hide it. Oh, that looks magic. That makes me feel so hungry. I feel like I want to fill it up with some chips or something like a snack or a salad. Probably chips with mayonnaise. Right. So this is where I'm getting the dimensions for the whiteboard lesson. We're getting 6 take away 2x. So I'm taking away 2 lots at corners. Yeah, can you see it? I'm saying 2 lots at corners. That's why 2x is coming out from 6. Yeah, you get that there. And as well for the 4 take away 2 lots of the corners. That's why I'm getting 4 take away 2x. Right. So there's one dimension missing here. So the other dimension, I'm just inserting that just now, just so you can see it. Did you see it? I don't know if I can write that in there. Aye, well, it's in there. I managed to put it in there. It's X. Oh, and that matches up exactly. Tommy, you're so good. So I've got my 3 dimensions: X, six, six with 2x, and 40 with 2x. So I'll get 3 expressions, and to get the volume, I just multiply them together. Right. So is it okay if I just bin that in? Right. Okay. So hopefully I can continue. That's how I got that box. That was absolutely fantastic. Right. So here we go. So it's length times breadth times height. There you go. I'm sure you can multiply that all out. You're experts at that now. Have you done it? Brilliant. Okay. Absolutely fantastic. Okay. So what we're looking at here, we're looking for the maximum minimum volume here. So I think we're looking for the maximum. And for maximum or minimum, it doesn't matter. I'll take you back here. The derivative has to be equal to 0. So that's what we're looking for here. Right, and I'm just putting in a wee thing here. Um, the x has to be between 0 and 2. I might explain that later. Okay? Just think about the constraints of the problems. 4 take over 2x and 6 take over 2x. Think about that. Think about that. Here we go. When 4 take over 2x has to be greater than 0, got to positive. 4 is greater than 2x. 2x is less than 4. I've just switched it around there for those that aren't paying attention. So that means x is less than 2. That's fine. Other one. 6 is take over 2x is greater than 0. 6 is greater than 2x. Switched it around. X is less than 3. Oh, we get 2 answers here. Let's come back to it later on. We'll come back to it later on, okay? Why does he do this to us? But anyway, so we'll get volume, we've got derivative, and I think, so let's make derivative equal to 0. Yep. And how did it go from there to there? Well, every time before, if, if numbers are divisible by a nice number, then I will divide it. So 12, 40, 24, forget about the negatives. 12, 40, 24, I've divided it by 4. Uh, I've divided by 4. Yeah, I've divided by 4 because they're all divisible 4. Yeah, I have. Why did I divide it by 4? Because I could, and because it makes it a lot nicer. Okay. So 3x squared to 10x plus 6. I'm looking at that. Can I factorize that? On initial inspection, I don't think I can. So I think I'm going to go for the quadratic formula here, and A, B, and C, they're coming from A is 3, B is -10, and C is 6. Okay, right, you're all familiar with this, so let's go for it. Right, there's the quadratic formula, numbers in, there you go, and I apologise, I think I've done my sorts things in my head. Yep, so don't you worry about that. I know you worry about things. I've done the 10 plus or minus root 28 is 6, and I've got that there, that there, that there. Do you want me to explain why I got down to there? Oh, please don't let me explain it. Jeez, oh. Right, see the root 28? That part there, I know that's a multiple of 4. That's 4 times 7, so I've got plus or minus 10 over 6, and a 10 is 2 times 5 plus or minus. And so what I've done, see the square root 4, you only take that out. So that there is actually 2 times the square root of 7 over 2 times, that would 2 times 3 in the bottom there. Okay, 2 times 3, and mathematics, the 2's will cancel out. But that, Tommy, that was very bad there. Shouldn't have scored out that 5. The 2's cancel out, okay, which leaves you with 5 plus or minus root 7 all over 3. Right, anyway, you can use a calculator and do this. You can actually use a calculator and it will give you that. Okay, are you all fine with that? I'm sorry about all this commotion. It is commotion, isn't it? So I'm just going to get rid of that. What do you think? So you should be able to go from this there to that line there, because you're used to surds and cancellation, and then so we're just going to separate it, because like I said, there's a plus or minus, so we'll get the 2 options here. Right, that's what we're going to go for here. If I take away root 7 over 3 and 5 plus root 7 over 3, can you please notice that I've used brackets here for the numerator or top part, whatever you want to call it, before I divided things by 3 and then I went for it. And so I've got approximations here because the answers were not nice, because root 7 is not nice, but I went for it. Right, so here we are here, and so maximum, minimum volume, the question was maximum. So we've got 2 values here, and like we're saying, which one are we going to go for, 0.78 or 2.55? 0.78 or 2.55? So, like we're saying here, there's constraints. I know I've written stuff in here, so I might actually dingy this and ignore this. So I'll get 4 taken by 2x and 6 taken by 2x. I don't want to have a negative answer for any of these. So 4 taken by 2x and 6 taken by 2x. So if either one of these gives me a negative answer, then it's binned. So 4 take away 2 times 0.78 is a positive answer. And 4 take away 2.5, 2.55, that's the negative answer. So that's ruled out. So that's why I'm going through this scenario here. So there they go. I'm putting in 0.78. Yep, positive answer, that's fine. I'm putting in 2.55. So I'm only using one of the constraints. As soon as I use one of the constraints, it rules out one of the dimensions. I'm fine. That is okay for me. So that is invalid. Are you okay with that? Rewind on that and actually go back to the dimension. You're not allowed to have 2.5, 2.55. Let's look at the diagram. 6 take away 4 take away 2 times 2.5 and a bit. That'd be a negative answer. So you're not allowed to have that. Do you get that? Doesn't matter about the 6 take away. That it's a 4 take away 2 times 2.55. Invalid answer. Okay. Right, so I've just went on with that, and that's fine. So, apologies for that there. So, if you want to use a nature table, then because I have shown you that, just to confirm, a lot of you, I like using nature tables, where we had our critical values here of 0.78 and 2.55. So the top row is x, the middle row is a derivative that we're going to insert values, and the bottom row is the nature or the shape. So here we go. We're going to look at numbers between 0.78 and 2.55. A number to the right of 2.55, a number to the left of 0.78, and a number between 0.78 and 2.55. It's up to you what values you find. But do you know what we're doing here is we're picking these numbers because we want to put them into the derivative at 2.78 and 2.55. You know, we'll get 0 and 0. That's how we got them initially. So 0.78, 2.55. So I've chosen one. I could have chosen two. Just pick a nice number, please. It'll make sense. So a number to the right of 2.55, I'll probably pick 3, and left of 0.78, I'll probably picked, what have I picked? I'll probably pick 0. I don't like picking 0, but I'll probably pick that. Yeah, there you go. Put those numbers 0, 1, and 3 into the derivative and see what answers we get. So are they going to be positive, negative, whatever? So there you go. There's for derivative. There's 0. That because 0 is on the left here. I'm putting that in. And I'm interested. It's positive. That's all I'm interested in. It's positive. Right. So next one is 1. It's between 0.78 and 255. Let's put that in. It's negative. That's fine. And the last one is 3. Let's put that into the derivative. And let's see what we get. Let's see what we get. It's a positive. So we've got all three answers: a positive, negative, and positive. Okay? Positive, negative, positive. What does that tell us about the slope? So derivative dy over dx is basically we're looking at slopes of curves here, and we talk about lines here, really tangents. So positive gradients, negative gradients, zero gradients. So that's what we're doing here. So the positive there, nature or shape. So what we're doing there, bottom left, top right, zero horizontal, negative, top left to bottom right, zero, again horizontal, and positive. There you go. So this last scenario here was just me showing you how to use a nature table for this entire question about this folded up box that gave us a maximum of 8.45. Let me see this. Just go back. Right, folks, I'm just going to go back here. In case you've lost the plot. It's not I have lost the plot. Or did I go in and solve for it? Right, I don't think I have solved for it. So I'm just going to continue. And if I haven't solved for it, I shall do so. Ah, yeah, there I have. I did that earlier. I did that earlier. I'm losing the plot myself. So I put in the legit value of 0.78. So I just want to confirm that myself. Put it on 0.78, whatever it was, an approximation. You can put in an exact value if you want. And save it in your calculator, that's fine. Put that into the original equation for the volume. Put that in there, and that will give you some kind of approximation for the volume there. Right, I'm going to leave that there, and that will do me. So if you had another version of that there, then I'm replacing it. Okay, so that's fine. Okay, right, bye for now, folks. Thank you and good night.